So next one is, we defined what is the LCM, right? The LCM we defined. So we'll use, let us see one application. So suppose sum of two positive numbers. So the sum is given by 5264, and the LCM is given by. So let us say the two positive numbers are suppose A and B. So their LCM is given by
l.c.m.
right. LCM is the least common multiple, right?
List the minimum.
Right.
Okay, okay.
Right. So the least common multiple. So that is given by this 6-digit number 200340. Right. So we have to determine the two numbers. So can we find the two numbers from this information? Their sum is given and
Some
their
men
LCM is given.
multiple.
Yes.
We have some. Just substitute is right. Oh,
Yes, tell.
yeah. We have a plus b
Hmm.
equal to this, and a multiply b
Right.
equal to this.
A multiplied by B, but the LCM they will have relation with the GCD, right? So
Not okay. LCG.
yes,
That's mean this can divide by two by both. Yeah.
right.
Mm, mm, mm.
So I think last we so we showed one result. So if you remember this result, that the GCD. So the GCD of these two integers is same as GCD of AB, A plus B, and their LCM, right? So we'll use this result. So let me state the result here. So GCD of AB is same as the GCD of A plus B. So the LCM, the notation we are using, this box of AB. So it is same as the GCD
Mm,
between A plus B and their LCM, right?
mm, mm,
So what do
mm,
you get?
mm.
So I have both of them. So A plus B is 5264, and their LCM is this is also given, right? So if I find the GCD,
Find the
so
GCD.
yes, can you tell how much will be the GCD?
Mm. GCD.
Right.
Uh, 526 and 200. GCD calculation. That's the
8,
28.
28, right? So GCD is 28. So I know this. So now we'll use the relation that the LCM is nothing but the product of two numbers divided by the GCD, right?
GC, GC. LCM.
Right. LCM is the product of two numbers divided by GCD. That is one relation we studied, right?
Oh, wait. LCM. Yeah, 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 yeah.
Right. So from here we'll get the product of two numbers. So AB is nothing but the GCD is 28 and the LCM is this number 200340. So that is nothing but you can check 5609250. Right. So we have two information. I have the sum of the numbers to be 5264
Mm,
and their product I know 5609225. So from here easily I can get the two numbers, right?
mm,
Just substituting one into the other I can get. So that calculation I think you can do. So it's 1484 and B I get as 379, right?
mm. Yeah, yeah. Mm,
Right. Okay. So next one is okay. So suppose the GCD of two numbers is 1. So GCD of AB is 1. So then there exist x and y positive, x greater than 0 and y greater than 0, such that ax minus by, this is 1.
mm. GCD, I mean, AX plus BY
Yes, yes. So if
equal
GCD
to
is
what?
1, we know that ax plus by is 1, but there was no restriction on x and y. So x and y could be
Oh,
positive, could be negative. But here there is a restriction that x and y has to be positive.
mm. Two positive. Mm. Two yeah.
Right?
Mm. AB maybe negative or positive is right.
Yes. So that we have to, yes, it can be negative, it can be positive. So AB are positive integers, so that is fine. So we are taking GCD of positive integers only. Okay. So let us see the proof. So suppose one of them is equal to 1. So suppose if A is equal to 1, then it is not very difficult.
Mm.
So then we take x to be b plus 1, right? And y to be 1. So then what happens is, then you can say that ax, so a is 1. So then you can see that easily this satisfies our equation,
Mm.
right? So 1 times of b plus 1 minus b, so that is 1, right?
Mm.
So this is fine. So here x and y both are positive. So we can
Yeah.
assume, so we can assume that a is strictly greater than 1 and b is also strictly greater than 1. So if one of them is 1, then we are done, right? So we can
Mm.
assume that both of them are strictly greater than 1, right? Right. So if both of them are strictly greater than 1, so since the GCD of AB is 1, by the Euclidean algorithm, I know that there exist x and y
Mm.
such that ax plus by is 1. So this we know, right?
Mm.
But now, if x is positive and y is negative, then we are done, right? So, so let us write like this. So this is capital X and capital Y, such that ax and by is 1.
Mm.
So if capital X is positive and capital Y is negative, then we can just choose our small x to be capital X and small y to be minus of capital Y, right? And then we are done.
Mm.
Okay.
Yeah, yeah, yeah.
Up to this fine. So now the only thing is if the combination is different, right?
Mm.
So the thing is x and y cannot be zero, right? So that is of course x and y
Oh,
cannot be zero. Both
yeah.
x and y cannot be zero, right?
Mm.
Right. So that is one observation. So let us make some few observations. So the first observation is uh, x is not equals to 0 and y is also not equals to 0
Mm.
since a and b are not equal to 1. Now the second point is x and y both cannot be negative.
Mm.
Right. So since then what we'll have? We have ax plus by. So this will be strictly less than 0, right? If both of them are negative.
Mm.
Because a and b are positive integers, right?
Yeah, yeah, yeah. Mm.
So both cannot be negative. Also both cannot be positive also, right? So x and y both cannot be positive. Since if both of them are positive, then ax plus by that will be strictly greater than 1, right?
Mm.
Because a and b are strictly greater, they are strictly greater than 1, right?
Mm.
Okay. So up to this is fine.
Yeah, it's okay. Mm.
Right. So what is the conclusion now? So one of them is negative and one of them is positive, right?
Mm. Mm.
So we can conclude that x is negative and y is positive.
Mm.
Okay. So next we define a sequence xn equals to x plus bn and yn as y minus n for
Mm. Mm.
it belongs to integer.
Mm.
Then what you can see is if we consider axn plus byn,
Mm.
right? So that is nothing but 1 again by our definition, right?
Mm.
So this we can take from natural numbers. Okay.
Mm.
So now we can increase n large enough. So this will work for any n belongs to natural numbers. So we can increase n large enough such that our xn becomes positive, xn becomes greater than 0 and yn becomes negative. That we
Mm.
can do, right? Always.
Yeah, yeah. Mm.
So that will get our result, right? So because I wanted x greater than 0 and y to be less than 0, right?
Mm.
So if I choose a large enough n, then this will become positive and this will become negative.
Mm. 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 Yeah, yeah. Mm.
Okay.
Mm. I guess Y I N I guess I N B Y. Ah, yeah. Mm.
Okay.
Go to one. Mm. Mm. Yeah, yeah, yeah.
Right. So let us see the last one. Okay. So suppose a is some integer that is strictly greater than 1. Then the GCD of a power m minus 1 and a power n minus 1. So this is nothing but a power of GCD of mn minus 1.
Oh. Ah. I. Ah. Ah. Yeah, yeah.
Okay.
Hmm. You see the up. Amen.